So with that, I would like to introduce our speaker today, Monte Niemi. He's with Recycled Tires. He's going to be talking about manufactured tire-derived aggregates, and he's been in the business forever and a day since 1981. Do the math, that's 37 years. He's been working with recycled tires and how to use recycled tires to kind of enhance, what we're doing for roadways and things like that. So he's going to be kind of going through and talking about the different aspects of that, some of the things he's seen over the years. And, he is an NRA member, and we truly appreciate him as associate members. So with that, Monte, go ahead and take it away.
Good morning. It is a blessing to be able to present on the cost savings and engineering benefits of tire-derived aggregate. This is going to be kind of a PowerPoint of our experiences and some of the research that's been going on. The agenda today, we're going to talk a little bit about first-aid tire recycling. We're going to have a drop box, and then in the drop box, we're going to have a lot of the research that papers and videos that people have done in regards to tire-derived aggregate. And so we're going to talk about that drop box a couple of times, or we're going to be talking about different types of research papers that people have done. I'll try to give credit to those people as we go through it, but I want to make sure that everybody recognizes that this is available. We're going to be talking about the 10 different engineering properties of TDA. We're going to talk about an eco-friendly filter zone and some of the ongoing research that's happening with tire-derived aggregate. As a society, we throw away 1 tire per person per year, and so that happens year in and year out. So in Minnesota, that's about 5 million tires. Our company happens to do about 2.5 to 3 million tires annually. 30% of those tires that come off our cars, we can turn around and reuse them in the automobile industry, either for retreading or for reuse. But 70% of those tires has no longer life as an automobile tire, and that's what we produce into tire-derived aggregate. There's no waste products in this process. The tires that are still usable as or retreadable, there's industry manuals teaching what we have to look for and doing the conditions of the tire. We sell 1 to 2 semi-loads of these tires every day back into the reuse marketplace. This is the drop box that we have the Google Dropbox with the different videos and stuff that are going to be in there. This research conservation challenge back in the, I think it was 90s, started out talking about how do we reuse some of our resources. It evolved into the scrap tire work group. Videos like this California video is in this Dropbox, and basically we're just trying to build an industry. There's more waste tires than there is marketplaces, and people are shredding these tires and bringing them to landfills just to dispose of them. And so the scrap tire work group says, let's since we know this material can be used in construction, let's figure out how to make tools available and educate both the processors that are making the material and the industry that has civil engineering needs. And so that's what these resources that we're going to be talking about today are trying to do. Federal EPA came up with a video of how and why to use the material and how environmental friendly it is. This is probably 10 years old now. This is one of the first products our work group put out. California has put different manuals, TDA usage guides, properties guides, talking about it from an environmental point of view, from a construction point of view. Here's another list of different videos that are currently available on how and why to use this material in different applications, all the way from cost savings to earthquake prevention for buildings, protecting the buildings. This work group here is over 100 members. Blake with our DOT is part of that group. Basically, we're just trying to build more marketplaces. This research pays off mentality is what this group has been doing, and California and other states have been doing a lot of research, and we're going to be talking about that research and how it applies to construction projects. But the scrap tire work group has kind of been a funnel on the civil engineering group part of it. As they come off our vehicles that no longer have life as a tire for grading, for reuse just go on a simple conveyor. We'll talk about the product a little bit here. It goes through a slow speed shearing process. So basically it's no high speed equipment, it's all slow speed, tight tolerance chambers, cutting that tire into different size pieces. To date, we've done over 62.5 million tires here in Minnesota alone going into these kind of projects. In the early days, we didn't know what size was their ideal size for our material, so they said, well, let's just make a single pass shred. It's a low cost material. It turns out it's going to be lightweight, so single pass shred is going to work. After we did that for about 8-10 years, ASTM came up with a specification talking about what size this material could be to have a national standard, and so that's where we get between this 12 and 305 millimeters in size. And so we end up having a little chart here saying there's so much material between 3 inches, so much between 8 inches, and so much everything under 12 inches. And so now we have a national standard. So this is called an ASTM Class B specification. In the early days, we ended up just making that single pass shred. And then when we made this transition into the ASTM started showing up on the jobs, and we didn't have the equipment to make that smaller material. So now we ended up putting 2 shredders in place so that we can end up having all the material go through and meet this Class B specification. We had so we don't have any problems with oversized material showing up on jobs anymore. Bob, can you put the video in, please?
Yeah, this is where things get tricky, so bear with us, please.
Yep. This video is a California video. It kind of talks about the history of tires and in the water table and some of the predispositions people have and concerned about putting tires in the water, and it kind of talks about from a scientific point of view the benefits of it. So I'm hoping it cues up.
Additionally, TDA has a higher permeability factor. It is lighter than regular drain rock aggregate and has an increased potential for developing a biofilm, which is an effective water quality treatment method. Biofilms support a healthy population of bacteria and other organisms that provide a favorable biological treatment of organics in drainage water. It is important to note that TDA can be used in projects where water is a factor, either running through it or sometimes suffusing it for a time. After water comes into contact with TDA, it will often run off and leave the site, draining and commingling with other surface or groundwater sources. In order to assess any potential harm to the environment, this drainage water was subjected to extensive water quality testing. The results of the tests performed on TDA found that regulatory limits were not exceeded for any of the targeted toxic compounds. Some of this extensive, rigorous water quality testing on TDA was performed here at Humboldt State University in Arcata, California. Dr. Brad Finney is an environmental resource engineer. Professor Finney and his research assistant, Rochella Maeda, have tested TDA over the last several years. Both their laboratory and field tests have shown that TDA does not exceed the maximum contaminant levels, which are California's potable water regulatory standards.
I've been working with water and wastewater for 45 years. And my first reaction to the idea of using TDA in a water environment was almost repulsion. I can't imagine why anybody would want to do such a thing. Much to my surprise, I found the opposite to be true. In our current work, where we've been using TDA in a stormwater treatment setting, so we have water goes through the TDA into the soil and then joining the groundwater setting. The concentrations that we observed below the TDA layer, now it's after the stormwater passed through the TDA layer and then a foot of soil below that, were always below what went into it from the stormwater. So it provided better treatment than just having had that stormwater going directly to the receiving water. A properly designed system should pose no risk to the receiving water quality. We tested for 67 different VOCs and found 2, benzene and MIBK, both of them at concentrations below appropriate regulatory standards. I have not found a single piece of data that I've collected that would indicate that there's any environmental risk associated with the use of TDA. There simply is not any concentration issues with any of the leachate compounds that would pose any risk to public health. It has incredibly useful engineering properties. We should be using it.
Here we'll just move on a little bit. The ASTM, with that, knowing that tire drive material used above the groundwater or below the groundwater, they recognize that TDA placed below the water table would be expected to have negligible off-site effect on water quality. Basically, they're saying the metals that come out of the steel belting on the tires goes about an inch or two into the soils and doesn't go any further than that. So essentially, they're saying there's no issues in using it, and that's the same results that California came up with. ASTM was supporting and the green building using the material in their manual here in 2015. In this particular case, they're talking about using the tire drive aggregate for its engineering property of reduced lateral loading. It has 50% the lateral loading, and so here in their green build materials book, they recommend using it behind walls. In Minnesota, the Pollution Control Agency obviously was not aware of the consequences of the effect of using tire drive aggregate, and so they started looking at all of our projects to go back in the early 80s. With the first 50-some projects we did, they came out and monitored each of our projects. To date, we've done over 300 projects, and after about 50 of them, they came back with this sonar where they said they hope to encourage the regulated community to utilize such materials when possible, and that led to their standing beneficial use determination where no permit is required. Under G, when it says tire shreds are used as a lightweight fuel in construction of public roads in accordance with the Minnesota statute, and that's a MnDOT statute. And then H is where about 95% of our material goes into these type of projects, where it says tire chips is when used as a substitute for conventional aggregate in construction projects when the ratio of substitution is no greater than 1-to-1 by volume. This does not include tire chips as general construction fill or clean fill. So essentially back in 2014, they're saying, go ahead and use this material as long as there's an engineering reason to use it and there's a benefit to it, not just disposal. So why would an engineer use the tire drive aggregate in their designs? And we believe there's 10 engineering properties that an engineer has in their toolbox after watching what's available with this material. The first one was where we started out back in the early 80s, and we recognized that it was lightweight, 600 pounds per cubic yard, 20 pounds per cubic foot. It compared to other lightweight materials, and it was very cost effective at $3-4 a yard. All the way back to 2016, there's some reference guides where they were doing research talking about the lightweight properties. And unfortunately, this is kind of where we got stuck for many years, thinking that the only use of this material was a lightweight material. But the lightweight usage guides back in '84, transportation here in Caltrans. The first project we did was an unloading project in '89 in the city of Eden Prairie for industrial park. They had taken a bunch of sand off across down 62 and they put it as a surcharge in this industrial park. This 10-foot surcharge had settled below grade and was still moving, so they had to remove the heavy soils, come back in with a lightweight aggregate. They chose a tire drive aggregate. They used this project as a research project to learn about this material. It was a very low-cost, lightweight aggregate compared to other materials. They recognized using the geotextile fabric and put the soil on top. They could get the material to settle. They got their settlement stakes and stuff in place. They were worried a little bit about curbs and gutters matching or moving, but now after 20-some years, 30 years, I guess, there's no problems with the project at all. It worked very well for them. So we started recognizing the lightweight use of the material for solving soil correction problems where heavy soils had failed. It was a solution. We have some compaction information now that started back on that project, but ASTM comes up with this documents of teaching how to predict your compaction, how to get your compaction. Talks about the 6 or 7 passes of a machine running over the top of it. This is what material looks like when it's loose volume. You're coming out of the back of the truck. It's 80 cubic yards of loose volume. That 80 loose volume yards compacts into 40 yards. But here's what it looks like when it's loose. The machine just sits down inside of it. This is before it's been run over 6 to 7 times with a track machine. So 70% of that loss of material is going to happen during that kneading process, where you run the heavy piece of equipment back and forth, turning the tracks as you're going, kind of kneading it into place. The last 30% is going to happen once you put the load on. But here's what the material looks like once it's been kneaded. You see that the material no longer rolls up around the tracks, and it's now it's ready for putting your soil on. It's buildable. It's easy to walk across this type of compacted material, where the first stuff was a bit hard to walk across with street shoes. With calculating that 30% of the compaction of how much higher do I put the fill than I actually want it, because it's going to compress under the load. And so they came up with some curves. And again, all these papers are in the Dropbox available for being able to predict where you want your final grade to be and how much material to put in there. And, I think this was 92, Pine City exit ramp. MnDOT had a ramp that failed when they put soil in. They came back in with 30,000 yards of tire drive aggregate. They ended up putting a fabric and a 4 to 5 foot soil cover on the material, putting a concrete surface, and now they put an overlay on it. Been many, 20 years plus, and it's still working well for them. Not heard of any movement in that project at all. Blue River County in 2010 in Mankato, they had a bridge abutment that they wanted to approach. It was sand. They had a train going underneath this railroad grade. The soil started making a mud wave and putting lateral load against the railroad tracks. So they ended up having to design a lightweight fill. They came in with a tire drive aggregate and removed that heavy soil that was causing that mud wave. Got the trains to be able to go back to full speed. They were able to build in that situation with the tire drive aggregate right up against the bridge abutment. They got some nice write-ups in the paper. They got a better safety factor. They got a 1.4 safety factor versus a 1.1 safety factor with the Shear key method. And so they got a nice governor's award for using creativity in their design and solving this problem. Back in 1990, another lightweight application was they had an underground parking lot at the Niemi Convention Center. They wanted to put a park on top of it. They used the tire drive aggregate for its lightweight nature. They also used it for its porosity because it was going to drain the water that came on top of it. They were able to put their sidewalks, their lighting, their trees. The park has worked well for them for many years, a couple of decades now. The lightweight uses of the material is in pipe bedding installations. Bolt and Mink here in Waconia had a pipe bedding situation where they had porous soils. They didn't want to put this additional load on top of those pipes with the porous soils underneath. They designed using a tire drive aggregate to make that blanket to protect those pipes. We were able to put the curbs and their sidewalks with a roadway on top. Again, very cost effective, cheaper than the wood chips and the styrofoam, a lot longer lasting. What we recognized, that first tool was the lightweight material. That's kind of where we got stuck for almost a decade or so. What we started recognizing as we had fixed some of these township roads with this material, that wherever we put the material, it didn't have any frost heaving. And you look at the upper right picture there, that's Larch Street that we had done the year previous in the city of East Bethel Street in the foreground, all the frost activity happening to it. And what we learned is that the tire drive material actually makes a porosity break or a capillary break where that moisture can't come back up to the surface. And here's some research that Dana Humphrey did back in '93 talking about that capillary break. This City of Robbinsdale project, you can see on the bituminous there, the System Engineering designed a solution because of the moisture working back up to the way and breaking up the bituminous surfacing. Well, the problem is you got moisture in the subgrade and you got porous soil. So they ended up excavating out the porous soils, coming in with a fabric and the tire drive aggregate, building around the stormwater systems, putting the aggregate in place, being it compacted. This particular project is when they were learning a little bit about that, how much overbuild do you put before it feels like you have too much material. The contractor, I think it was a 4,000 yard job and about 3,200 yards. He said, hold on, don't deliver no more. It looks like we're already at the height of the sidewalks and we got to get our 18 inches of cover material on top of this yet. And so we had worked with the the engineer and the contractor, we did a little test section where they kneaded it into place and they put the load on top of it, and they ended up meeting all 4,000 yards. But it ends up being in this particular step where people say, oh, gee, this isn't going to settle into place, and that's where those compaction data comes in pretty handy. But here at the end of 2000, there's, it all worked out good with the sidewalks and the curbs. 2016, they did an overlay, but there was no cracks, there was no maintenance for 16 years of a project. They're having to put annual maintenance into doing patch repairs, moisture issues, frost heaving every year. Now they've been 16 years without any maintenance at all. So this is a way that the city of Robbinsdale is saying this is cost savings for them, not only in construction but also long term. They have another project for us here in 2018. There were some nice write-ups in the paper for them. City of New Brighton, Kimberly Horn Associates designed a project here where they had frost heaving here in the neighborhood. They ended up excavating out some of the poor soils, putting in our tire drive aggregate, just a regular neighborhood city street that was getting a lot of frost activity, moisture issues. 2 weeks later, they had it paved. 2 years later, the roadway, you'd hardly know that they even had any problems with it. So when they went in, they designed a solution. They used the material for solving a problem that they had, and the problem went away. So again, engineers using the engineering properties of material to solve problems. This is that large street in 245th Street where you can see the frost heaving in the city street that we did not do. In the springtime, for Athens Township, we've done 14 different projects. So we do a little bus tour in the springtime where people, when the frost is coming out of the ground, you can drive down the road and you can see where the tire sections are because there's no frost activity, no moisture issues, where the rest of the roadway has some frost activity happening. So if a person has a problem project, this material will remedy that for getting rid of that capillary. Here's a project in Carleton County for Highway 61, a bridge approach. You can see all the cracking and the bituminous coming up to the bridge there on the St. Louis River. Just a small shallow fill, just a couple foot fill of tire drive aggregate to make that capillary break. Now 2 years later, there's no cracks, no movement, no nothing on that roadway. So where moisture was an issue, just a small amount of tires, small amount of yards of material solved the problem for them. Other uses, because this doesn't allow capillary action, so now we have some people building buildings on top of it, just a floating slab construction because there's no frost activity. You don't need a deep footing. And so here in this business here in the Bruin exit, built 5-7 feet of tire drive aggregate, put his whole parking lot, put his building on a floating slab. It's been in place here for 20 years. Been no movement to the slab. My garage slab cracks up. There's no cracks in that slab at all. Next engineering reason that people are using the material is the shear strength. In the early days, we knew this material was really strong, and we thought that, gee, if we use this on a road crossing soft soils, we'd sink the road before we'd ever get it to shear off, but we didn't have no data. So the research pays off. Now researchers have gone and done the work to show how strong this material really is. And so California put together a shear machine that was able to do large scale direct shear of material. Hopefully this next video will work.
Dr. Patrick Fox built a large machine to test the stress capabilities of TDA here at the University of California, San Diego. His findings prove TDA possesses superior stress capabilities compared to standard road fill materials.
The direct shear machine here at UCSD is the largest of its kind in the world. It measures 10 feet long by 6 feet high by 4 feet wide. The test results today were very significant because for the first time we were able to measure the full stress strain curve for the TDA material. In today's test we had 14,700 pounds acting down on the TDA, and it required over 17,000 pounds to tear it apart laterally. What that actually tells us is that the TDA is a very strong material compared to natural soil, and therefore is more desirable for construction.
The shear strength of this material and how incredibly strong it is compared to soils. When you have shear failures, a strong material is really advantageous. So here's a project in Bismarck, North Dakota back in 2009 that Ron Intertech said we got some shearing going off here in this roadway. We got some shearing going on here in this bicycle path next to it. This is along the Missouri River. And so they came up with a design to remove the heavy load that was causing or adding to the shear failure. They wanted to use a material that was going to be free draining, so it didn't add any extra moisture. You could control the moisture, not adding to the shear failure. They decided to drive some pilings along the very face of the river, so the face of the river did not get abused during the construction, so they didn't fall into the river itself. And so here's some photos of the material being removed that was causing the failure. Here's where they drive the pilings of the photo on the left-hand side there. Here they're coming back in with the tire drive aggregate for the shear strength of the material, for the lightweight nature of the material, and for the drainage properties of the material. Here is a view of how this looks next to the Missouri River with the material getting compaction there. And so they got the fabric on top, they got the 18 inches of soil. And to get this material to bottom out, in the early days, we didn't know, do we need 5 feet of material? Do we need 3 feet of material? How much do you need? And what we've recognized just through the 300 some projects, that you need a minimum of 18 inches of soil on top to get the rebound out of the rubber. And so on all projects, we recommend having a minimum of 18 inches. Most of the time we end up seeing 18 inches plus the 6 inches for whatever your driving surface is going to be. And so here they got the soil in place, they got the bicycle path back in place, the roadways back in place in 2009. Now 7 years later, here in 2016, this photo is taken. You never know that there was shear failure going on in that area. 2018, there's no issue. So again, using the material for its properties. Here's a number of projects Joaquim Wright talked about a few weeks ago at Mid Roads here about the slide failures, the shear failures they had in California, where they used tire drive aggregate to repair the slide areas. Here's a similar project here on Highway 8 going into Taylor's Falls back in '94. You can see the guardrail and the cracks coming into the fog line there. In '94, they decided to excavate out the heavy materials that was causing that. I was not involved in this project, but they brought in the tire drive aggregate and were able to build the embankment around the stormwater system. Got it closed up in I think it was a 4 or 5 day period, if I remember right. Now, many years later, there's no more cracks, there's no more sliding, there's no more shearing going on in that area. The next property, that's a tool that's in our toolbox here, is this material has reduced lateral loading. So against a retaining wall, against a structural wall, it applies 50% of the weight of soil. So here's the photo there in the middle where they have a 4.5 meters of tire drive aggregate. They remove the wall away and it stands vertical. So basically, it's pretty much a very good material for behind walls. Here's research papers that they put together by Humphrey and Stanford talking about the reduced lateral loading back in 1993.
TDA's light weight produces only half the normal pressure against the sides of retaining walls and bridge abutments compared to traditional road fill materials. This is a cost benefit because it allows for the reduction in the amount of reinforced steel and concrete needed for many of these engineering applications.
Okay, I think you've got it. Yep, you've got it.
Okay, and so with that reduced lateral loading, understanding that it has 50% the weight of soils, how that comes into play is when you have sensitive structures that you want to affect and don't have a negative effect. Here, Washington Avenue Bridge here in 2006, Bolt and Mink said, we want to put a cartway underneath this old bridge and we don't want to add any additional lateral load to these old bridge supports here. And we got already so much load against them with the soils. And so they decided to remove the soil, and they were able to remove heavy soil, come back in with twice as much tire drive aggregate, and not add any additional load to those bridge supports. So here's they're coming in with the tire drive aggregate, not adding any load to that wall, and able to get their emergency access cartway for the Twin Stadium here. And so, again, engineers using the material for engineering solutions in very sensitive situations because of the engineering properties it has and the research that went into it that pays off to come up with good solutions for this recycled material. Here's in Hy-Vee grocery store in Robbinsdale. They backed this building up against this hill. They didn't want to have the load of this hill or the soils or the moisture putting lateral load against their wall. So they came in with our tire drive aggregate and they started backfilling this wall because of the reduced lateral loading, the moisture control. One thing we have not talked about yet is that the tire shreds have 8 times the insulating value of soil. So against a wall like this, not only are we keeping the lateral load off of it, we're keeping the moisture off of it, keeping that moisture quite a few feet away from the wall, but we're also adding an insulator layer. It's about an R5 per foot, and so you end up insulating this wall besides. They're very able to, they built that project in January when all the other soils on the site were frozen. This material was not affected by the cold or the being frozen. It plays just fine for them. Here's a project we're doing currently in the city of Chaska where they're backfilling this apartment building. They're going to have 24 feet of this material backfilling this structure here. Again, using it for the engineering properties, using it for the insulation properties, using it for the drainage properties, other walls that have been used because of the reduced lateral loading. Here, our EPA came up with a manual of how and why to use recycled materials back in 2009, and they talk about it for its superior drainage, insulation, and wall pressure relief. Next property we're going to be talking about is the interlocking property, how this material kind of makes a snowshoe effect over soft ground. And so we have some references here in San Diego. We have an interlocking.
One interesting property of TDA is that it has an internal reinforcement due to the fibrous nature of the particles. Because TDA is made of rubber pieces, it has exceptional properties with regard to damping vibrations. These vibrations might come from a passing train, for example, or passing traffic on a highway, or from an earthquake. Those rubber pieces are elastic, spongy, they're soft, they absorb vibration very well, much better than natural soils.
Video I'm going to just pass over, but basically this works like a big snowshoe over soft ground. This Coon Rapids Commerce Center here is on top of a swamp. It's about a couple thousand acre swamp. MFRA Engineering, now Sambeck and Ron Intertech decided to design a build on top of this poor soils. They excavated out where they were going to put the Perkins, and then they ended up with a 5-acre pad in the photo on the right where they're going to be putting a number of businesses on top of that 5-acre pad. As you look at this print here, the roadway and the frontage road going along Highway 10, that's all on top of 5 to 7 feet of tire drive aggregate. And on the far right-hand side, there's 5 acres of 5 feet of tire drive aggregate that those different blocks on top there are different businesses that are on top of it. So they got the tire shreds in place. They got the 2 feet of soil to get the rebound out of the rubber. And now you got your Caribou Coffees, your Jimmy John's, your taco shops. This has been a number of years. There's no movement in the parking lot. There's no movement to the soils away from the buildings. On top of 45 feet of peat, very hard to build this project into your Mark Anderson basically saying this is the only cost-effective long-time solution for that site. You look across, walk out in the swamp, and you look back at that development, that 5 to 7 feet of elevation and that 5 acres is basically the tire drive aggregate that brought it up out of the poor soils there. Similarly, in Needham Prairie in 2002, this whole Purgatory Creek Park here, all these structures were on top of our tire drive aggregate. That building in the background was the only thing that was there when we first got to the site. Basically, they had a wetland that they had to get a permit. They wanted to fill the wetland with their tire drive aggregate. They ended up bringing in 5 to 7 feet of tire drive aggregate, putting the fabric on top, putting the soil up on top. Now they have the Veterans Memorial up on top of it. They got the gazebos, everything on top of it. It's been many years. There's no movement of anything. It worked very well for them. Looking across the pond at that development, that 5 to 7 feet of elevation is basically made the snowshoe effect, floating that whole embankment on top of the soft ground out there. It also works on trails. Here's Lake McClusick Trail in 2006 in Stillwater. got out there, they froze it down. We brought our tire drive material across the frozen mud, put our shreds out there. They came back with the soil up on top of it when it's frozen. A few years later, it was solid enough they could run a paver across, basically making a frost-free, maintenance-free trail on top there, because there's no capillary action going to happen, no differential settlement. The shear strength, the snowshoe effect on top of that soft ground. Black Bear Casino in 2001 up in Carlton. I'm from the Cloquet area, so when I heard they were putting a golf course out there in the Tamarack Swamp, I went and talked to them. I said, bet you'll need some lightweight fill in that swamp out there. And they said, no, we got it under control. And so all of a sudden in the 9th fairway, they lost their scraper in the bottom of the fairway. So they said, oh, we need some lightweight fill out here in the 9th fairway. And so we started delivering material for their 9th fairway. And then we started talking to the managers there, and we talked about the snowshoe effect and the capillary break, and they decided to put our tire drive aggregate underneath all their golf cart paths. So wherever they have a paved golf cart path, they have our tire drive aggregate under it, and that way they don't have no maintenance to their golf cart paths. Different businesses. Here's a mini storage here in Hermantown, a nonprofit wanted to put on top of the swamp here, that photo on the left. They wanted to fill that swamp and put a mini storage on top of it. They put our tire drive aggregate out there. Floated the businesses, floated the buildings out there. In Prairie Ford in '88, they wanted to fill a swamp that the south half, their parking lots on top of 20-some feet of peat. Our tire drive aggregates floating that car lot for them. Flying J in Albert Lee in 2008, they needed to support their parking lot for all their trucks and stuff they have on their site, using our tire drive aggregate for the snowshoe effect. The next engineering property that we'll be talking about in our toolbox is the permeability. They talk about it's between 1 and 30 cms per second how fast it flows. ASTM has some reference guides on it. It really works well for French drains or edge drains or drainage trenches. We'll be talking about a few of those. Here's a Caltrans paper back in '84 talking about the permeability. Again, St. Louis County did a project using it for the edge drain, get that moisture away from the moisture going to come through the soil, but it's got to go someplace. So you backfill these pipes with the tire drive aggregate, and the water flows through here as good as it does the pipe. You can see in this picture here, this is the previous ASTM material. That's a little bit larger material in these pictures. Prior Lake High School had a drainage trench that they needed to build underground drainage trench, so they used our tire drive aggregate for moving water underground. Their drain tile applications, pulse backfilling drain tile applications, using it for insulating reduced lateral loading against the foundation walls. Septic systems, and Anoka County Parks Department use it in their parks for their flow zones because of the permeability of the material. Work very well for them. Next, we're going to talk about the void space. When this material is in place, compacted with the soil on top, it still has a 50% void space. And when Joaquin Wright talks about using it for the void space for the stormwater system, he says it has twice of that of a typical aggregate. And the best we could find is that the granite had a 35 to 40% void space, but tire drive aggregate has a 50% void space. And here's Professor Humphreys doing his research showing how this void space, documenting the void space in the material and how it can be used. Here in 2006, Gradewood Elementary, we're going to use it for storing the stormwater for the school. The yellow area there is where their new parking lot's going to go. They're going to put a stormwater retention pond underneath the parking lot. And so here they excavated out the soils in that area. They came back in with the tire drive aggregate to use it for the void space in the material. Here they got the parking lot back on top of it. No movement, no differential settlement, no frost activity, met their stormwater requirements. Worked very well for them, very inexpensive. Westwood Elementary in 2005, this actually was the first stormwater system we put in 2005. Used our tire drive aggregate. They didn't know what they needed for distribution pipes for getting the water through the tire drive aggregate. So they kind of built an H-size perf pipe setup, but we've learned that it's not necessary. The water flows through without that. Got it completed, parking lots on top of it. Works very well, no movement. St. Paul Port Authority in 2010 on the 3M site, they wanted to deal with the stormwater pond. Lopes Associates, Ratio Contracting, said all this water coming from the north is going to come onto our site. We need to put a huge stormwater system in here to control the stormwater. So they decided to build this huge trench, and they put these massive pipe in there. And then they, because the pipe had 100% void space, our TDA had a 50% void space, and so they wanted to control as much water as they could. What we recognize is that these pipes need to be supported on the bottom 50% with soil, because the tire drive aggregate does not have the same lateral loading as soil does, so these pipes need to be supported at least 50%, and so this is what is recommended. This system worked very well for them. 2010, 2016, the development is done. With that in mind, they coined the phrase the next generation stormwater system, the St. Paul Port Authority. And so now, comparing to the chambers and comparing to open ponds, they feel that this is the superior product. And so when they did in 2015, they did the old Saints Stadium, the Midway Office Complex. They doing the same situation. They excavated out the size of the pond they needed, taking all the water on all sides of the building and running it into the stormwater system. Supported the pipe 50% with soil, using the tire drive aggregate for the void space in the job. This particular job, Bolander, I believe, did the work, and they came and got the material for free. So they did the trucking. So essentially, it was costing them about $2 or $3 a yard to truck the material to the job site. That's pretty typical. What material is showing up on job sites is between $3 and $5 a cubic yard. Again, getting it placed compared to the granite and other rock is, probably 1/5 the cost. is a video showing the equipment compacting it, but I don't believe it's going to play. But this wall of this building is right on the edge of the stormwater pond, and this parking lot's right over the top of the pond, and it was very straightforward. They ended up using porous pavers and porous concrete on top for allowing the water to get into the stormwater chamber. They ended up with a conventional collection basins and stuff for the stormwater. Very much a success of this project. This is a auto salvage in St. Paul that Wink designed a stormwater system. They were on a contaminated site. They have contaminated soils on the site. They're crushing cars. They didn't want their business to affect the contaminated soils underneath, so they put a watertight liner underneath their stormwater pond, and so that and they use the tire drive aggregate for the void space, and then all the effluent that comes out of here can be tested and kept separate than the contaminated ground that's underneath. They're able to crush cars and work on top of this stormwater pond without any effect on the stormwater system at all. The rain gardens using the material for the void space. Again, engineers using the material for its engineering properties to solve problems and building green besides, and saving money. Vibration mitigation. Tire drive aggregate, because it's rubber, it's very resilient. California used it underneath their rail lines for their commuter trains, their light rail. It works very well. It's a huge cost savings. They have a video about how much it saves. Again, I'm afraid this video probably won't play again. Get the rail lines.
Light rail commuter trains often transmit low, noisy vibrations as they pass by homes and businesses. CalRecycle has researched the value of using TDA to lessen the vibrations caused by these trains. This sound mitigation is inexpensively achieved by using only 12 inches of tire-derived aggregate under the light rail tracks, which reduces ground-borne vibrations to the surrounding areas. TDA material can perform better than floating concrete slab vibration mitigation and is 15 times more cost-effective, which has saved BART, LA Metro, and VTA millions of dollars.
We installed over 3,000 linear feet of the TDA trackway, and the net effect of that was over $1 million in savings on our project.
Today, in a number of California communities, light rail trains travel through bedroom communities early in the morning and late at night, very, very quietly.
Is being used not only in California, but Colorado and Texas. On some of the older rail lines, they're not interested in changing the bed of the tracks at all, but vibration is still an issue. California is recommending putting these vibration trenches alongside the vibration source, either the highways or the railroads, and these trenches will catch the ground-borne vibration and get rid of the noise and get rid of the vibration. This is also the concept that they're using for these bomb-proofing buildings and stuff, where a blast will come and the vibration from the blast vibrates to the soil and does destruction to the building. So they're looking at using the tire drive aggregate in these trenches to catch that vibration and stop the vibration from doing harm. The next property we're going to be talking about is the thermal insulation properties. Again, these engineers are saying, here's the reason I want to use it, because it solves this problem. Well, here, the insulating property, 8 times that of soil around geothermal heating systems, around basement backfillings. Again, we have engineers doing these reference usage guides showing how it works and how the research pays off, where tire drive aggregate prevents the frost from penetrating the ground, getting rid of the frost issues. Around a home, it's a R5 per foot. So when you're backfilling homes with 3-4 feet of material, you're insulating. Here in Carleton County, put a maintenance garage in. They put a geothermal heating system in. They're heating and cooling the building. Their transference lines, they didn't want to be affected by the surface sun or cold, so they ended up using our tire drive aggregate over the top of the system to insulate it. again, using these heat pump coils. Next area here is a building foundation, and they're backfilling this building for the insulating properties, but this is kind of unique where they put a crane on top of 10 feet of tire drive aggregate, and they're going to lift this building on top. You can look at the footpad here of this crane. We were worried that at the bottom right here that we're going to get some cracks in here. Starts to lift this building in place, but you can see after the building's been swung into place that there's no cracks around that pad. So just with a couple feet of soil or sand on top of the tire drive aggregate, they're able to run a 60-ton crane and swing a building in place without any cracking or movement. So it really is pretty impressive as far as how strong it is. It's not a cure-all, obviously, but when the engineers are designing uses for it, it has had quite a few benefits. The filtration factor, this is probably the one that's made the biggest impact most recently, and we got some nice videos in regards to it, and I'm afraid these videos won't play, but we talk about removing pesticides and nitrates and phosphorus. Professor building for the insulating properties, but this is kind of unique where they put a crane on top of 10 feet of tire drive aggregate, and they're going to lift this building on top. You can look at the footpad here of this crane. We were worried that at the bottom right here that we're going to get some cracks in here. Starts to lift this building in place, but you can see after the building's been swung into place that there's no cracks around that pad. So just with a couple feet of soil or sand on top of the tire drive aggregate, they're able to run a 60-ton crane and swing a building in place without any cracking or movement. So it really is pretty impressive as far as how strong it is. It's not a cure-all, obviously, but when the engineers are designing uses for it, it has had quite a few benefits. The filtration factor, this is probably the one that's made the biggest impact most recently, and we got some nice videos in regards to it, and I'm afraid these videos won't play, but we talk about removing pesticides and nitrates and phosphorus. Professor Parks at the University of Wisconsin has been doing research for I think about 10 or 12 years now on how the tire drive aggregate, the carbon, the steel can benefit removing these pesticides, nitrates, and phosphorus.
Phosphorus is a component of RNA, DNA, and ATP, and it's a common material in fertilizers, manures, and organic matters. Phosphate was selected as a representative of a component because it is one of the major resources of phosphorus in water bodies. Phosphate is one of the major components of crop fertilizers. When it rains, the runoff rainwater collects a lot of nutrients, including phosphate, as it travels to nearby stream to be deposited into the watershed. Too much phosphorus in a water body can cause eutrophication, a reduction in dissolved oxygen due to growth and decay of algae, bacteria, and other tiny organisms. High eutrophic levels can cause a decrease in biodiversity and lead to algae blooms. This picture shows an area of Lake Monte that is unswimmable due to high eutrophic levels caused by pollution from phosphorus and other nutrients. This picture was taken in July of 2017.
The current farming solutions to this problem are based on reducing the amount of fertilizer used, managing livestock waste, and mitigating erosion. A strip of grass or buffer installed between a crop field and a stream reduces the erosion on the stream's banks, as well as acting as a filter for the nutrient-rich wastewater flowing into the stream. While these vegetated buffer strips are effective, they often do not lead to a significant reduction in the nutrient pollution.
Mitigated by the use of tire drive aggregate. Eco-friendly filter zone, improving water quality. Again, Parks is talking about tire rubber is capable of absorbing toxic organic and inorganic compounds when concentrations in the surrounding environment are high. And then out of 51 pesticides, 37 pesticides were estimated to be removed with a tire rubber layer thickness of this thickness in a typical scenario. So again, these videos that are going to be in the Dropbox will be more explanatory, but these are the conclusions essentially, that tire derived material is not contaminating our environment, but it's actually cleaning it up. And so there's different uses of this material to help clean up our stormwater, clean up our ponds, get rid of the phosphorus. Here is some more work by Parks where he talks about the results showing that he tested the tire derived aggregate in 3 different types of water environment for making sure that the different types of water environment that we weren't going to get any negative impact from the tire derived material. And that, excuse me.
Hey, Monte, we're kind of running out of the hour here.
Okay, essentially we're at the end of the presentation. So we're just talking about how it cleans the pesticides, nitrates, and phosphorus. California did a stormwater pond where use a tire derived aggregate, take the stormwater off the street, run it through the filters, reduced iron by 10, manganese by a factor of half, zinc by a factor of 10. So there's a lot of good engineering, a lot of good research showing how this material can remove these properties. Again, that's the end of the presentation, but essentially there's 10 engineering reasons that are, help a person use this material. It's not just lightweight. It solves a number of problems once you know what the problem, what the properties are here. Thank you. Is there any questions?
Yeah, Monte, thank you very much. It's really an opportunity to have an associate member like you talk about your product. We're kind of running out of the time. We keep these to an hour. If people have questions, please contact Monte. I think he did a great job of kind of showing how this materials can be used. There's always been concerns in the past, but this kind of helped some of my thoughts, at least when you presented it. So thank you very much with that. Our next research seminar is going to be August 21st, Tuesday, 10 to 11 again. Our speaker fell through, so if you have ideas on what we'd like to hear, please let us know, Bob or myself or anyone part of MnDOT. We'll get that and kind of work on that for the next time. But again, thanks to Monte. Thanks for getting up early. I know you're out in Spokane, Washington right now. It's a lot earlier out there, but it's great to have you present, and thank you very much.
Thank you for the privilege, and I really appreciate this research pays off, because this is a testimony to all the research that's gone into this one industry, and now we can share it and get this technology transfer. The industry, the waste tire industry, really needs to build a marketplace, and these are the efforts that we're going through.
All right, thank you, Lonnie.
Thank you.
Thanks, everyone.